All right. So what's another way to name the second triangle? I just wrote CBQ. Okay. BCQ, good. Another way?
QBC.
What?
QBC.
CBQ?
No, QBC.
Oh, QBC. I thought you said CBC, and I was like, there's only one C. All right, how about the next one? I started by naming it WYZ. Okay?
ZWY.
Okay, ZWY. You could also have started at Y. You could have said YWZ or YZW. Any order, it doesn't matter. There's a ton of ways to name these triangles. All right, the last one I put KJM. What's another way?
MJK.
MJK, good. Next.
JKM.
JKM. Good job. Again, tons of different ways to name it. So just because yours isn't up there doesn't mean you named it wrong. It just means there's a different way. Okay. Last thing on this page is angles versus sides. So when we get to classifying on the next page, you have to know angles and you have to know sides. So let's go ahead and label. I'm going to name this triangle A, B, C, and we'll name this one D, E, F. So make sure that you're putting the letters in the right spots, because when we're talking about certain side lengths, I want to make sure that we're looking at the same side. When we get over to classifying, we have to know the angle pieces. Did you bring some?
I'll put all of you in my kitchen table.
Look at you. Here you go. I'm going to have to make you another pack of highlighters about that. There you go. We'll only need 3 today, I think. If not, I'll give you more. All right. So how do I name this angle right here? How do I name that angle?
ABC.
I can't name it ABC. Remember, the vertex has to be in the middle.
BAC.
Okay,
Oh,
BAC is one. Angle BAC.
CAB.
Okay, good. I could start at C and go up to A. How can I name it one other way? It's one other way to name that angle. No, can't do BCA. If I put C in the middle, then that's a different vertex.
ABC.
If I change B and put B in the middle, then that's a different angle.
Would it just be A?
Yes, Cheyenne, it would just be angle A. So remember, when it's sitting by itself like that and it's not adjacent to anything, I can just call that angle A. So what I'm going to do is highlight this little angle right here. I'm just going to put a box around all these names. Those are all the different ways to name that angle. When we get to classifying, we have to know where angles are located. So being able to name them is very, very important. All right. How do I name the double curved angle?
CBA.
CBA, good. Remember, if we're naming with 3 letters, the vertex has to be in the middle. Okay, I need 2 more.
ABC.
Good. ABC, so angle ABC
And B.
and angle B. Good job, guys. So things to remember. As you're naming angles, make sure that you're putting the angle symbol that we talked about at the very beginning. If you don't put the angle symbol, I don't know if you're talking about a plane or if you're talking about a point. So you've got to put the angle symbol. Okay, practicing naming angles. All right, we've got our very last one. I'm going to put 3 curves here. How do I name the 3 curved angle?
BCA.
Okay, BCA, so angle BCA. Good. Next.
ACB.
Good job, Nick. ACB. And angle C. Good job, Alexis. There we go.
John.
So as you're naming these angles, it just takes a little practice. The way that you name angles, you envision yourself tracing the angle out. It makes it a lot easier to be able to name them. Franklin, Luis, you need to put your cameras on. Bless you. All right, so angles, there's lots of different ways to name angles. If they're just sitting kind of by themselves, then you can name it with one letter. But if they're adjacent, you have to use 3. So that's why we're practicing all the methods. All right, let's practice naming sides. So to mark a side, we put bars. How do I name this single bar side? DE. And since this is a segment, how do I put the segment symbol? What does that look like? What's the segment symbol look like? I have to put it above it. This is from junior year. It's been a while. I know Coach Webb taught you this. It's okay if you don't remember.
I feel like this is going to get very difficult.
I promise that this is super easy.
Why?
It's a line, and it looks like this. That's the symbol for segment. That's all. See? Not hard. What's another way I could name that segment? Good. I can name it ED as well with the symbol. Yeah, I can name it Ed. So I'm going to highlight this whole side here. Those are the only 2 ways to name a segment. You name them with the end points. So the 2 letters kind of represent the boundaries of the segment. It starts at D and ends at E, or starts at E and ends at D. All right. Let's name this double barred one down here. How do I name that one? DF or FT. Good job. Remember, put your symbol above it. Both of those are perfectly acceptable names when naming segments. Okay. Take a second and name the third one. E what?
Yeah.
EF, good. And FE. Geometry is very, very picky when it comes to notation. So you have to put the little symbols up above the segment. You also have to put the angle symbol in front of the angles. Geometry is very picky when it comes to notation. So this is all that background stuff that you might have forgotten from junior year. And then on the next page, we're going to do classifying. To classify, we're going to have to know where sides are located, and we're going to have to know where angles are located. So to recap, I'm going to go up to the top. Okay, real quick to make sure, oops, a little too quick. Triangle symbol is a little triangle. Angle symbol is a little angle. Acute angles are between 0 and 90. Right angles are equal to 90. And obtuse angles are between 90 and 180. Go back down. To name triangles, we use 3 letters. You have to put the triangle symbol and follow a pattern. And then when naming and identifying segments and angles, oops, wrong direction. You got to put the angle symbol for angles, and then segment symbol for segment. All right, you ready to classify? Good. The silence makes me believe that we are. Okay, we are. Okay, there we go. All right, let's classify. So all that review stuff, we're going to get to the real math. No algebra involved, just identifying. There are 2 ways to identify types of triangles. One is by their angles, which is why we repeat it. The second is by their sides. So we classify angles by angles or by sides. So the first one, let's go ahead and put these measurements inside of our triangle. 89, 50, and 41. To classify a triangle by its angles, classify a triangle by its angles, we're going to put 50, 89, and 41. All right. How do I know that that triangle is called an acute triangle? I'm naming it by its angles. How do I know that that triangle is acute? What is it?
It doesn't have a 90-degree angle.
Okay, it doesn't have a 90-degree angle, but obtuse triangles don't have to have a 90 degree.
They go past 90.
No, those don't go past 90.
I got the other one. Obtuse.
Obtuse go past 90, so let's kind of refocus those thoughts. So what is an acute triangle?
Less than 90.
All the angles are less than 90. There we go. So acute triangle, all angles. And I'm going to put the angle symbol. If you want to write the word, that's fine. But remember, the more you use a symbol, the easier it is to remember. So all angles are less than 90. So by knowing the definition of acute, this makes it a lot more easy. We know acute angles are less than 90 but greater than 0. So acute, they're all less than 90. And if I look at my angles, I have 50, 89, and 41. Even though angle 89 is really close to 90, it's not 90. So it's not a right angle. Okay. So you have to make sure that you're putting your angle symbol if we're identifying. So in this case, we're not writing anything down, so we're good. But just know your angle symbol. Okay. Louise Franklin, if you guys don't put your cameras on, I have to kick you out of class. So I'm giving you one more warning. Okay, so acute triangles. All the angles are less than 90. So looking at that picture, they're all less than 90. All right, what do we think a right triangle has?
90-degree.
How many?
1.
Just one. If we had two 90-degree angles, it would already equal 180, and we have to have three angles that equal 180. So a right triangle has one 90-degree angle. So one angle is equal to 90. Okay, so I'm going to put a 30 up here. Oh, that's a 36. I wanted to put a 30. Yeah. 30, 60. How do I draw?
A square.
Good, the square, that's right here. So that one is equal to 90. So that little box tells me. Now, just because my other two are 30 and 60, they are acute. A right triangle, it's more powerful when you have a 90-degree angle. Like that trumps the acute angles. So it's just a 90-degree angle, which is a right triangle. We will spend a whole chapter on only right triangles. Okay, so acute, all the angles are 90. And a right triangle, one angle is 90. Okay, what's an obtuse triangle?
More than 90.
How many angles are more than 90?
Anything more than 90.
Can all three of them be more than 90? Just one. So an obtuse triangle has one angle greater than 90. So one angle is greater than 90. And obviously it's less than 180 because all the angles have to add up to 180. Okay? So I'm going to make this big one over here 100. And then we'll make the other ones 50 and 30. Notice how they all still add up to 180, but one of them is bigger than 90. So obtuse, greater than 90. All it takes is one. For it to be classified as acute, all of them have to be less than 90. But for them to be classified as right or right triangle or obtuse, has to be greater than 90. Okay? Now the very last one is called equiangular.
I mean, we're all angry.
All the things are equal. What are all the angle measures if it's equiangular?
45?
Okay, well, let's think about that. Is 45 plus 45 plus 45 180?
No.
No, so they can't all be 45.
60.
60. There we go. 60 plus 60 plus 60 is 180. So equiangular might look like a weird word. Okay, it's spelled a little weird. Equiangular, let's kind of just piece it apart. The equa part right here, that means equal. Angular means angle. Equal angle. That's it. So even though the word is like really weird looking, you can piece it apart. It just means equal angles. All the angles are equal. And we were told that they were all 60. So I'm going to go ahead and put curves. Remember, the curves mean that they are all the same. If they all have one curve, they're all equal. And Gabe said that they were all 60, which is correct. So all angles are equal. All angles are equal. Now, technically, yes, it is acute, because they're all 60. That's all less than 90. But we want the most specific terminology when we're classifying. So if they all happen to be 60, we don't want to call it acute. We want to call it equiangular. So yes, it is acute. But we want the most specific terminology when we're classifying. So those are technically equiangular. And that only happens when all of the angles are 60. So equiangular will only happen when they're all 60. Technically they're acute, but we want specifics here. So equiangular. Oh, I'm sorry, let me get you another hot water. You can use the fruit if you want to. You do it. You do you. I just wanted to give you the other option. I didn't realize. All right. Now those are all sides or angles. I'm sorry. These are all angles. Now we're going to classify by sides. Okay. So angles, if they're all 60, they're called equiangular. All right. Let's hop on down, or I guess up to sides. So side measurements, we're going to talk about a theorem called the hinge theorem and the triangle inequality theorem that talks about sides of triangles. But for right now, we're just going to talk about in terms of general, and equal or not equal. What do we think equilateral triangles have?
Sides are equal.
All the sides are equal. Good. So if we're going to break up that word, the equal part right here is equal. Lateral meaning sides. So this just means all sides are congruent. How do I draw the congruent symbol? I forgot how to do it.
Oh, they equal with the.
Good job. It's an equal with a little squiggle. We got our equal sign with a squiggle. I don't know the mathematical term for that squiggle when it's on top of it. If it's not, it's called a similarity symbol. But when it's on top of that equal sign, I really don't know the math term for it. Just a little squiggle. So that means congruent. How do we show that each side is the same measurement? What should we draw?
One line.
1 bar. Good. 1, 1, 1. So equilateral, okay, equilateral means that this side, and this side are equal. They're all the same. They're all going to be the same measurement. Equilateral, equal sides. Okay, so equilateral is our first one. This next kind of triangle we're going to be spending a lot of time with later. I know, later on in our chapter. It's a super important type of triangle. So equilateral, all the sides are the same. Next, we're going to isosceles. What do we think is true about the sides of an isosceles triangle?
One side is the more than the other. So one That's two sides are equal, but one is not.
Good. Two sides are equal and one is not. So for the two sides that are equal, we're going to put bars on them. How many bars should this one that's not equal to anything have?
1, 2.
Two. Yeah, if we put one on there, we don't want to put one because that would mean that's equal to all of them. So isosceles, which we're going to spend a lot of time with here in the next couple days, isosceles triangles have two sides congruent. And if we were to put numbers in here, that could just be like this side is 6 centimeters and this side is 6 centimeters. So in our picture, we've got two equal sides, okay, two equal sides and one oddball. It's not equal to anything. Okay, so these words are a little tricky. They're hard to read. That word is spelled super weird. And if I talk and try to write it, I always misspell it. So isosceles triangles, two sides are congruent or equal. You can use the symbol or you can write the word. All right. What do we think scaling is? No sides are equal. So how do we draw no sides are equal on our sides? Good. 1, 2, and 3. Good job. See, y'all remember something from junior year. Sorry, my camera is hard to control. All right, there we go. So I'll put 1 here, 2 here, 3 here. Doesn't matter. You can put the 1 anywhere else, but you don't want any repetition. Okay. So scalene is no congruent sides, meaning all of these side lengths are different. This one's different from this one, and we're using the different colors to symbolize different measures. Kind of make it a little more visual for you. When we're done with this page notes, I'll do lunch count real quick. I think it's corn dog nugget day. So scalene, no equal sides. Okay. All right, so to classify, we can classify by angles, we can classify by sides. We're going to practice both today. I know, practice is terrible. Using the things we learn, it's just why do it? I just want to torture you. That's why. All right, as we classify, I'm going to tell you one little trick. Okay. Let me see if I can get this to fit the whole page. Kind of. There we go. Nope, I gotta hold it or it's not gonna work. Okay, so here is your trick. If a triangle is equiangular, I have to hold my camera, so I'm gonna let go of it real quick. If you have an equiangular triangle, it will always be, see if I can, there you go. It will always be equilateral. These two will always go together forever and always. They're match made in heaven. They will always go together. If a triangle is equiangular, it will always be equilateral. Now the other ones you can mix together. Like I could have a right scalene triangle or a right isosceles triangle. But equiangular will always go to equilateral. It will never go to anything else. Okay, so that one is kind of a trick. Those two, they always stick together. The other classifications can mix together. I can have an obtuse isosceles triangle, an obtuse scalene. Okay? But equilateral and equiangular always stick together. BFFs for life. Okay? So what can I clarify? What questions do you have looking at this page?
Question.
Yeah.
Can there be two right angles?
Okay, that's a good question. Can there be two right angles?
Because I don't think they have to make a triangle.
Yeah, you don't think they can make a triangle. Let's test that theory right here. I like that question. So can we have a triangle with two right angles? Well, let's draw a right angle.
I think the question is like a square. You can't afford a triangle anymore.
Right, this is not a triangle. Remember, triangles have to have three sides that connect. But if I make 2 of them 90, I'm already at 180. I need 3 to equal 180. So I can never have a triangle that has 2 right angles, ever. That's a really good question. Yeah, it's not possible. A square would work, but can't have 2. Any other questions or concerns or, anything? All right, turn to the next page, page 11. Don't be intimidated by page 11. Okay, page 11 is exactly like the page we just did, only now I put numbers there. That's it. So all you have to do on page 11, I'm going to turn this page. I'll be scanning these notes and putting them on the Google site during 3rd period. So all you have to do on page 11 is you're just going to write angle, and you can write S for side. Classify it by angle, classify it by side. So if you're looking at angles, you look inside where the degrees are. If we're classifying it by side, we look outside where the sides are. All right. Yeah, I can do one with you. Let's look at number 1. Let's look at all those angles. What are the angle measurements for number 1? 57, 77, and 46. What do we know about all these angles? They're what? They're less than 90, making them what? Acute. So if we're naming this triangle by angles, we're going to call this a what? Acute triangle. That's it. That's all you have to do. Look at the angles. The angles are inside. And when I look at those angles, I see that they're all less than 90. Okay, now let's look at the sides. So my side measurements, I have 7.2, 8.4, and 9.8. Do I have any congruency with those sides? No, none of them are the same. So what's the name of the triangle when none of them are the same? Scalene. So this is a scalene triangle. And that's it. Now, you could also write this as a combined sentence, basically. We could call it a scalene acute triangle or an acute scalene. Whichever method. Like you can write them together, write them separate, but they can go together if you want to. Okay? So we're going to classify by angles, classify by sides. Do we feel a little bit more confident now? Yeah, just try them out. The answers are not, I guess not the answers, but the notes you took are on page 10. Sorry, you have to flip back and forth. Okay?